Hello viewers, this is Chemniverse, and in this video, you are going to learn about a world-destroying process. Electrolysis is capable of disintegrating the world into fine particles, only if you can submerge the world in a beaker of solvent. So, remember the first point. To electrolyze any substance, it has to be in a solution or molten state, so that it can conduct electricity. Insulators do not participate in electrolysis. Electrolysis is a disintegration process of an ionic compound using electricity, where a chemical change of that substance occurs. The substance which is disintegrated by electrolysis is known as an electrolyte. Again, the substance that you want to electrolyze must associate in its ionic form in an aqueous solution or molten state. For example, you will not be able to electrolyze sodium chloride in its solid form. If you dissolve sodium chloride in water, it will dissociate into sodium cation and chloride ion, which on electrolysis forms sodium, chlorine gas, oxygen, and hydrogen in different conditions. Now, let's draw a simple electrolytic cell. To electrolyze a substance, you will need an electrolytic cell. An electrolytic cell is made of a battery, two electrodes, and an electrolyte solution. A battery is the power source that releases the forces as electrons to the electrolyte solution through the electrodes. The electrodes are two metal or non-metal conductors which carry electricity to the electrolyte solution. The anode is known as the positive electrode, and the cathode is known as the negative electrode. Why? The power source pumps electrons away from the anode and into the cathode. Since the anode can take an electron from the electrolyte, oxidation occurs at the anode, and similarly, reduction at the cathode. The electrolyte solution is the solution of the desired compound in a suitable solvent. To explain what happens in an electrolytic cell, let us examine the disintegration of molten sodium chloride into sodium metal and chlorine gas. If molten sodium chloride is placed into the container and inert electrodes of carbon are inserted, attached to the positive and negative terminals of a battery, an electrolytic reaction will occur. Electrons from the negative terminal travel to the cathode and are used to reduce sodium ions into sodium atoms. The sodium will plate onto the cathode as it forms. The sodium ion is migrating towards the cathode. The negative chloride ions migrate towards the anode and release electrons as they oxidize to form chlorine atoms. The chlorine atoms will combine to form chlorine gas, which will bubble away. Note that the side of oxidation is still the anode, and the side of reduction is still the cathode. But the charges on these two electrodes are reversed. The anode is now positively charged, and the cathode has a negative charge. The conditions under which the electrolyte cell operates are very important. The substance that is the strongest reducing agent, meaning the substance with the highest standard cell potential value, will undergo oxidation. The substance that is the strongest oxidizing agent will be reduced. If an aqueous solution of sodium chloride were used in the above system, hydrogen would undergo reduction instead of sodium, because it is a stronger oxidizing agent than sodium. You can also quantify the electricity used in the process. That's the talk of another video. Until then, take care.